Good morning. Since this is an international conference and I am Portuguese, I think it's a good idea to share with you a tiny trait of what it means to be Portuguese, something that can be quite peculiar, however, we are extremely proud of. Here, you will see a small clip on one of those narrow streets from Portugal. This one is in Porto. And that bus can make the turn because that car is badly parked. What could we do? We could even call the police, ask for a tow truck. However, just a small group of people decided to lift the car and put it on the sidewalk. This is what we call desenrascar. It's the Portuguese word for when you solve something with suboptimal tools. Okay? You be creative, you find something around, and you quickly address the thing that you need to address. This is both a blessing and a curse, to be honest, because while we are more than capable of addressing any type of situation, almost like MacGyver, also, sometimes this backfires. For example, now, if a wheelchair wants to go through the sidewalk, he can't. Okay? And this type of approach is quite common here in Portugal. But that often leads to the lack of transformation, because transformation requires something else. Requires challenges, learning with those challenges, and taking it to an extra step, suffering with that in a way that you don't know how to get out of that. Luckily, there's a ton of stories about that, about transformation. And I love storytelling, so I would love to share with you some insights. Most of the stories follow conventions, patterns, formulas. The same way that we use design patterns, they have the same thing. So you can draw common shapes from the most successful stories. For example, let's use The Lion King by Disney as an example. If we draw two axes, one that goes from N, where N stands for negative value, so every single thing is going wrong, to P, positive value, perfect, every single thing is perfect. And another axis that goes from B to E, where B stands for beginning, and E stands for ending, so the end of the story, we can start trying to draw a shape of the Lion King. In the beginning, Mufasa has his firstborn, Simba. Everyone is super excited because not only there's the future king there, but also there's another thing that is quite important. Simba is so confident, he really wants to be the king. He's so full of himself, he's so confident, he's almost arrogant. Okay? He wants to be the king, he wants to be it now if possible. Because of that, he starts to get in trouble. Things start to go wrong. And now, every single thing goes to a bad place once Mufasa dies. And Mufasa dies because Scar, the bad guy, sets a trap, taking advantage of those characteristics from Simba. Sorry for the spoilers, by the way. And now, Simba runs away because he realizes that maybe it was his fault. And now the king is dead. Every single thing is wrong at this moment, okay? It's painful. And if we stop the story here, it's just one sad story about the lion. What makes it special, what makes us connect, is the transformation that will happen. But for that transformation to happen, we first needed that peak of inflated expectations on Simba. And now Simba needs to learn with his mistakes. So he will do a journey, will face dragons, he will face himself, and will need to learn with it. So by the end, he can return, be better than it used to be, and conquer the kingdom again. Most transformational stories go through this shape. Most Disney stories go through this shape. Love stories from the real life go through this shape. Okay? You might relate to that. And I honestly believe that to achieve that transformation that we need to fall in love with TDD, we need something that is here, we need to go through the same journey. My name is Guilherme. It's extremely hard to pronounce, so everyone calls me Gui. And I try to record a ton of content on test-driven development for a simple reason. In fact, it changed me. I also have built a course on that, But I realized that nothing like that can address one problem that we have in this community. That is the fact that you go online looking for information on how to master test-driven development, and the only thing that you find is people arguing with each other on Reddit, on X, or Twitter, or whatever you want to call it. They are just angry snobs fighting each other. And in one hand, you have those that will say, this is the best thing ever. You just don't get it. It's not for you. You are not capable of doing that. The same way that when my dog was just a puppy, I would say that he couldn't learn tricks, because what's the kind of dog that can't learn tricks? I was just putting the shame on him. Okay? That was my attitude. On the other hand of the camp, you have those that say that TDD is just a waste of time. It's one of those things that, okay, it might work for some people, but often is a waste of time. And why they say that? Often they say that because, in fact, they tried it. In fact, they tried to do something with it. They tried to practice it. However, they came to the conclusion that the tests became too hard to maintain, mostly because they were coupled to the structure. Any change to the structure of the code would be a problem. If any change to the structure of the code is a problem, refactoring is extremely hard. So they start realizing that this development process that everyone says that is quite fast, the TDD cycle, in fact is quite slow, and often at the expense of tiny, dumb little tests. So it's fair that they feel this. It's fair that they say that TDD doesn't work. It's fair that they say that it's not for them. However, I honestly believe that when you have two camps fighting each other, and one side, they are so extreme, okay? One side is just throwing things into the other side, and they are just arguing about everything, but I feel that they are not arguing about what matters. There should be a common ground here in the middle. So let me tell you my story on how I got to TDD. There was one day that is quite clear on my mind. It was a Friday afternoon. I called home to say to my wife that I wouldn't go home for dinner. It wouldn't be a problem if this was not happening so often. I used to work at a company where the deadlines were quite aggressive, and we just missed one, and we promised the client that we would desenrascar something on that Friday. Okay? So we decided to stay late. We ordered pizza. We kept working. We fixed everything, smoke tested it, pushed it to production. We went home. It was extremely late. I recall walking to my car. It was night, and the only thing that I could think of was going home to relax. But when I was just approaching my car, I could feel my phone buzzing. And on that moment, even before looking to the phone, I realized that I was going home not to relax, but to fix yet another problem. Oddly enough, on the day after, I finished reading the book that I was reading at the time, and I went to my bookshelf, and there was one book that got my attention. That is this one, Test-Driven Development by Example by Kent Beck. Not because I've never seen this book before. I have read it before. However, when I've read it before, it didn't work for me. It's not for me. This thing doesn't work. Okay? It's a nonsense. That was the way that I was approaching it. But this time, for whatever reason, maybe because we have tried so many things, from integration tests to end-to-end tests, we tried everything, and nothing worked. I told myself, let's commit to this for 6 months. Let's try again. If it works, perfect. If it doesn't work, at least I tried it in a serious way. And let me tell you something. It didn't solve everything. Okay? It's not a silver bullet. It's not by the fact that you practice TDD that the world will be perfect. No, that's not true. However, I deeply feel that it changed me. It was so transformative for me to a point that today I'm here. But I don't say this with a perspective of arrogance, like you should do it, because most of the best developers that I know and I had the pleasure to work with, they didn't practice TDD at all. But they are amazing. I'm not as good as them. What TDD changed me was by giving me the tools, the habits, the frameworks, the ways of thinking about code that made me better. I needed a structured way to approach the code. And that was what TDD had for me. That was the change. That was the transformation. So it was because of that that I was going through that journey, and at first, I stopped there. But now when I said to myself, let's commit for 6 months, I could learn like Simba and get out of there. That is what happened to me. I can't promise that by the end, you will love TDD. However, it's a great tool in many scenarios. What I can promise is that once you start walking to the journey, you know where you are going to. Someone said to you that it will be amazing. That journey will be hard. You will face many challenges, many dragons, many things that you need to fight. But eventually, it can pay off. And all starts in a simple place. It starts in the famous red-green refactoring. And no, it's not a mistake that all the boxes are painted green. I've studied, and according to a psychology effect named the power of suggestion, if I show you enough green, on the way out, you will take the correct decision, okay? So it's something that I've been trying to use the power of psychology for that. If you trust science, just do it. TDD follows this simple shape, right? Simple cycle. Red, green, refactoring. Looks so simple. What can go wrong? The problem with simple things, and I love them, is that sometimes the context keeps changing with history. We keep evolving it, everyone keeps talking about it, but eventually the message is not the same as in the beginning. Like in that kids game that you use the broken phone, not sure if you play that in your country, but here in Portugal, the kids have a game where they do the broken phone. So someone calls to the other one, gives a message, after 5, 6, 7 different people, the message is different. And the same happens in software, because the original idea might be one, but if someone takes the interpretation in a different way, something might be lost. And when you go to the origins of TDD, you start realizing that there's something missing here. There's something that no one talks about here. But most of those that are experienced with it, they do it. There is something that we call the test list. The test list is the idea that before writing your first failing test, you will offload every single thing that comes to mind into somewhere. It might be pen and paper, okay? Wrong choice of colors. It might be pen and paper, like I do. It might be, for example, your Notes app. It might be a code comment inside of your IDE. Use the tool that you prefer. But the idea is that before starting to write code, we have a moment of thinking, of offloading every single thing that comes to mind. And why do we do that? Because as the author of Getting Things Done, that is a famous productivity methodology he likes to say, David Allen, he says that our brain is made to process information, not to store that information. We can't store so many things in our short memory as the ones that we would love to do. Okay? But we have the tendency of trying to do that. Once you start writing things into there, you will see that your next decision becomes quite clear. I often like to say that TDD is like getting things done for developers. Getting things done is the productivity methodology that helps you to collect information and take the next decision in an easy way. Because once you write every single thing down with pen and paper, taking the decision of the next feature that you need to implement becomes quite easy. Because the biggest idea of TDD is finding the small thing that you need to do after. That's the idea. So once you start writing things down, and it might be one idea for a test case, it might be an idea for a corner case that needs to be checked, it might be an idea for a refactoring. Every single thing during the process goes into that page. Once you go to write your next failing test, you have a place that you look, and you can use your brain to say, this one will take me 1 minute or 2 minutes, and I can move to the next one. This way we can do those tiny little steps. When you don't write those things, we basically rely on our memory to find the closest thing. However, we might have lost the context, right? Because the way that we work is that often we start here, we have an idea of a corner case, we go here, we have an idea for another corner case, we go here, and eventually we forgot what we were about to do. Okay? That's the goal of writing that test list. Once you have the test list, writing your first failing test is quite easy. But the first dragon that you'll need to face here is the temptation to write a ton of tests at once. Since you have the test cases, why not writing all the failing tests at once? Looks logical. But if you do that, you will lose the opportunity of taking those tiny steps, okay, of finding that something might be wrong even on your test list. That's the goal. So you take one step at a time, only one. Your goal is to get out of red as soon as possible. But it will be hard because we are so used to use our IDEs, and now you need to fight with your IDE. Your IDE will start suggesting things, usually, but now that you are writing the test first, the code doesn't exist, so it can't suggest anything. There's no method there. There's no class there. So how do I write the tests? And everyone tends to have this tendency of, once they start writing the failing test, they realize that they don't have IntelliSense, they don't have autocomplete, so they go to the other place where the code will live, and will create the class, will create the method, will create the signature, will create an interface, and then go back to the test and take advantage of IntelliSense. Why this is a problem? Because the failing test is the moment of daydreaming, of thinking about the best possible developer experience for anyone that will be using that code. So that friction that you feel on typing every single word in your IDE is quite informative. Once you do it in the other side, you won't go back there to change it if something is going wrong, because you don't even notice it, because you are using your IntelliSense. So this pain, this friction, is part of the process. Avoiding it might lead to a scenario where things don't go as well as they should be, because TDD is a designing methodology as well. It's the idea that we provide the best design as possible to someone using our code. And don't worry, because if your code is not compiling, it's still a failing test, okay? When the code doesn't compile, it's still a failing test, no worry. But the biggest dragon of the red stage is the fact that once you get used to write the failing test, and then you run it, and you see the red light, you will start thinking, if the code doesn't exist yet, why should I run it? Right? The test will fail. It's obvious that it will fail. Why should I run it? So you start skipping the execution of those tests, right? You keep going. You just ignore that part. But that might lead to a problem. That might lead to the problem that you don't know if it actually works. Because if I can't assert, if I can't check that the test is failing, how can I be sure that I implemented the correct test or the correct thing? Is the assertion implemented in the proper way? Is it the implementation already there? Sometimes it happened. It happened in the past when I was writing a failing test and the test went green right away. The feature was already there, and I didn't know. Sometimes you find the surprise of the test going green because the arrange step, the setup of the test, is not correct. Or you might realize that the behavior that you are trying to assert should be asserted in a different way. Okay? That's why it's important to always run those tests, okay, to see them failing, even when it feels obvious that they will fail. That will take you to green. And green tends to be one of the most challenging ones for developers, for a simple reason. We get used to do things in a way, and eventually we think that they are fine, and we start to get frustrated with the way that people do things. For example, when you learn TDD, everyone in books, tutorials, and every single thing will say that to implement something like the sum of two numbers, what you will do is something like this. You sum 1 plus 2 should be 3, so you implement that the sum of A and B should return 3. That's the first step. Then you go to the next step. Next step, another test case. 2 plus 2 should be 4. What do? if statement, if A is equal to 2, it should return 4. This is what the books say that you should do. Okay? Then what do you do? Another test case. 3 plus 2, 5. What do you do? A plus 2 will make all those tests go green. And you keep going through this process until you finally reach the conclusion that there's nothing else to be done unless A plus B. It's basically that. Tiny little dumb steps. Everyone says that you should do it this way. The problem is that this is so frustrating. We know how to sum two numbers. And in reality, they teach us to do this in this way for a simple reason. They want you to implement the things that are obvious right away. If you know how to sum two numbers, just do it. Return A plus B. But if you are trying to do it and the test fails, that might be suspicious. You thought it was obvious, you thought it would be simple, you thought it would be easy, and now you are surprised. On such moments, you can shift gears. You are going high velocity, and now you need to shift gears and use a different approach. And when things are going to that territory where you don't know how things will go or why this is happening, you can use those tiny little dumb steps. Okay? Otherwise, it's just a waste of time. But for the fact that we learn to do it that way, many believe that TDD needs to be done that way. But that's unproductive. But that doesn't mean that you should implement the full solution right away. Another tendency that we have as developers, for a simple reason. We have an idea on how things should be by the end. We have an idea how elegant the things should be by the end, right? So we have been doing this for a long time. But let me tell you a story. I used to work with someone that no one in my team liked to touch his code. We liked him, he was a good guy, but no one liked to touch his code. It was a nightmare. It was quite clear that he was just copying the code from the internet and pasting it and trying to put things together. Oddly enough, the managers, the product managers, the product owners, they loved him. For a simple reason. While we were all concerned on the best technology, the design patterns, creating the foundations, he was coming back to them, reducing the risk of the project by showing up results, progress, by showing up that there was something wrong with requirements, some clarification needed. And sometimes we need to put on side this idea of trying to build things in the perfect way. And the green stage is that moment. It's the moment where you can be a duct tape programmer, someone that goes online, copy code from Stack Overflow, copy from a blog post, and doesn't touch that code. I know it's hard to get there. Let's make this an AI talk. This is the moment where you go online and you use GitHub Copilot or something like that, or ChatGPT, and you use the code as it is. Okay? And why that doesn't matter? For a simple reason. There's a stage after this one that is the refactoring stage where you will remove all of those sins. But you shouldn't do it right away when you try to go from red to green. Otherwise, it takes so much time, and the design might not be the one that you are looking for. Once you get to the refactoring stage, there's something that tends to be a problem. That is the fact that is the last stage. What do we do to last stages? We skip them, right? When we need, we skip them. When we have the pressure, we skip them. That's why when we try to do the refactoring only by the end of the development cycle, no one does it, and it just becomes backlog, right? Or technical debt. That's why TDD does it in every single iteration. So in every single iteration, you need to at least look into the code and ask the question, can I make this code better? Can I make these tests better? That doesn't mean, can I use the solid principles? That doesn't mean, can I use clean code? Okay? Make the code simple. Make the code maintainable. Think about the next few steps. If you look at this and you stop now, are you proud of the thing that you have been building? Okay? This is the moment for that. The worst part of refactoring, to be honest, is this one. We have the natural tendency to have tests during the refactoring. We are refactoring code, and we keep adding tests to the code. If you have a new case for a test, it should be when we are going to the red stage. Why do I say that? Let's use into the definition of refactoring by Michael Fowler. Michael says that refactoring is that moment where you change the internal structure of the code, the internal elements, but nothing changes from the outside. Imagine a bookshelf. A bookshelf is made to hold books, to store those books. If I go to my bookshelf and I move around the books, I try to categorize them, for example, by category, by name, by color, whatever, I'm just trying to change the internal structure of the books, so then when I need to access them, it becomes easier. So I'm simplifying the future use of that thing. I'm improving it. I'm changing the internal structure to have an improvement. But I didn't change anything from the bookshelf perspective. The bookshelf is still made to store those books. But when we work with code, what we do is that we are reorganizing the bookshelf, and we are just changing the shape of our bookshelf at the same time and giving it extra functionalities, all of those things. And doing that can backfire. We'll see that in a moment. Once you master all of these things, what I can promise is that this cycle has no secrets, okay? It's just this. So you move on, and you know that there's different types of tests. There's unit tests, integration tests, end-to-end tests, functional tests, manual tests, so many different types of tests. So you'll look online for a reference on how to do those. Why? You are so confident with the TDDing part that you want to understand where you should do TDD or not. So you find this reference, but eventually, by the way, this shape means that you should have a ton of unit tests. They are quite fast, quite stable. The ones on the top take more time. They are more fragile. They have more risk. However, a single test on the top covers more use cases than the one on the bottom. So you start realizing something. I'm doing TDD, so I always creating a failing test for any new behavior. That means that I will have, for example, the same behavior being covered here and here. Now I have duplication. Everyone says that duplication isn't a good thing, right? So I try to avoid that duplication, and I go online, and everyone is saying that I should be doing this instead. The, how they call it, the diamond. Okay? And diamonds are fancy, so why not? They are luxurious. The problem with this approach is that if you are practicing TDD, eventually can backfire. Because this test set, to run it, will not take just 2 seconds. It might take 10, might take 20, 30, 60, or even more. And in TDD cycle, you need to run the tests a lot, so frequently that it seems impossible, that you are running it after moving from red to green, after moving from green to refactoring, in every single attempt to refactor the code. You run it so often that if it takes 60 seconds to run, I promise that eventually you don't run them. And what happens in those moments is that you are changing the code and you implement now a given feature. You don't run the test because it will take 1 minute, so you move to the next one. Implement that one. OK, I will run the test later. Go to the next one. Now the tests fail. What's the reason? I need to clarify which change breaks the tests. And that takes time. That requires going back and trying to dig into that. And the goal of TDD is avoiding that time of trying to find explanations. Because things are so small that it's quite obvious what I need to do next. Honestly, I don't see a big problem with this one, besides naming. But we know that naming is hard. And unit test is really a terrible name, in my opinion. I don't have a better name. Not even, I don't have a good definition of what a unit test is. But I have an excellent definition of what a unit test is not. It's by Michael Feathers. Michael says that a unit test is not something that will touch a database, calls an API, goes across the network, publishes a message, or, for example, access your file system that needs to go to the environment variables. In other words, if your code can't run in a perfect isolated bubble, it's not a unit test. Okay? That's the definition. And why this matter? Because if we start thinking about this, and we try to map this to architectures that we usually use to structure our code, we can find something quite interesting that will simplify the process of practicing TDD and have more success during that process. Let's take a look. This is the base of hexagonal architecture, also known as ports and adapters. If you have been working with something like onion architecture, clean architecture, for example, or the principles of DDD, for example, all of them come from this one. Historically, if we go to the origins of those, the authors say that this was the base. And why this was the base? Because this is so simple and at the same time so powerful. The idea is quite simple. According to the author, your hexagon will contain every single line of code that makes your code special. Okay? So the reason why you were hired to build that thing, it will be there. And he came to the conclusion that all software have basically just two parts, an internal part and an external part. The external is messy, is unstable, it can break at any time, we don't control it, we don't know what will happen. Is the internet, is the operating system, is every single thing. But inside of this, we have control. Okay? Is the thing that we are crafting. But no software can live without touching the outside, right? Otherwise, it would be useless. So we need a way to bridge those two worlds together. And he creates this idea of ports. Ports are basically interfaces or contracts to the outside world. So that means that we can define some of them. Let's use an example to make this more clear. Imagine that we are building an invoice generator. Every single thing that is calculating discounts, calculating the totals, doing validations, all of that stuff goes inside of the hexagon. But then your hexagon can say to the outside world, hey, I'm capable of generating invoices, but I need to store them somewhere. I will give you this object that represents an invoice. Please put it somewhere. So now someone can look into that contract and say, I will implement a small translation layer from that object to transact SQL, and that way I can insert into a SQL database. Also, your hexagon can say something like, hey there, I'm capable of calculating discounts, applying validation rules, do all of that stuff. So if you have an invoice that you want to create, just call this method with this object. So now you can implement a small translation layer on top to implement an API, to implement a web application, to implement a message handler. And why this is important, and why I'm talking about architecture when we are talking about TDD. Because if we put this together with the explanation that I used by Michael Feathers of what a unit test is not, we can find something quite interesting. All the code that makes our test not a unit test will live inside of those bubbles. Every single thing that is here can be executed in a perfect, isolated bubble. So that means that you can find something like this. I love the animation, by the way. I can do it again if you want. This is why you came to this room, just because of the animation. On the base, we have all the core of our application, the unit tests. Those unit tests, we know that all the code that is there can be unit testable because every single thing that makes it not a unit test is here. That also means that since the hexagon exposes contracts to the outside world, we can test the adapters that are the small translation layers to the outside world as an integration test directly, without needing to go through this thing over and over again. That means that on the top, obviously, we need to have something like a safety net to make sure that every single thing plays well together. And if you do this, and you start doing this in every single layer, you might find problems if you try to apply TDD in every single layer. Because TDD is great for this part. It works perfectly for unit tests. It's so simple, so easy, and you get used to it quite easily. If you are just starting, start only with these ones. Because here, the effort is slightly higher. You need to have an extra effort of setup. You need to make sure that your cycle is fast enough to keep up with integration tests as well. So they tend to be a bit more flaky. So it might go wrong. I will not say that you shouldn't use it, but it's harder. I recommend starting here. Often it works on integration on the top. I usually don't do it. Because by then, you are already defined the behaviors of your application by covering those two. Okay? So there is something that you can do afterwards. As I told you, TDD is one extra tool. It's not the only tool. It's not the one that you need to be using in every single thing that you do. Okay? By the way, if you are doing something like a spike, a prototype, TDD is not worthy, because eventually you might throw away those tests. If you are trying to come up with the user experience of an UI, usually it's not worthy. If there's logic on that UI, it's useful. However, something like first click here, then click here, usually is not worthy to practice TDD on such cases. Doing all of this, you will be so happy because now you have so many tests. You are covering many layers. You start seeing your tests expanding. You feel more safe. So you start striving for something like a big number on your test coverage. You try to find, for example, 80% of test coverage, or having a goal of 100% would be awesome, right? The problem is that, in fact, test coverage doesn't say anything about your tests. It doesn't say if your tests are good or not. Test coverage is something else. I like to see them as a heat map. So, for example, in football matches, it's quite common that by the end, we might see the heat map of a player inside of a pitch. It's something like this. You can see that that player, during the game, spent most of his time somewhere there. Your code is basically the pitch. Your test coverage is saying that your tests went there. No test came here. Okay? It's just that. It doesn't say if your tests are good or bad. It doesn't say if you are writing the proper assertions. It doesn't say any like that. So using them as a goal is not ideal. What you can do instead is start looking at that coverage as a metric, as a tool to understand where should I invest more time. But combine that metric with other metrics, like, for example, knowing how many bugs do we have? Is someone complaining quite often? What's our development speed? Instead of saying, hey, from now on, we are striving for 80%. That's useless. It's vanity, to be honest. What you can use instead to learn something about your tests, to know if you are writing good tests, proper tests, is using this tool, mutation testing. It's an approach that will say if you are writing good assertions. It's an approach to say if you are writing good tests. Can you use them as a goal? No, because they might give you suggestions that are useless. Okay? They are that extra mile that is not worthy. However, as a learning tool, it's amazing. If I'm practicing TDD over and over again, I can run mutation testing once in a while, and I might spot things like, I usually forget to test the scenario with a null. I usually will forget to test the scenario when I have a collection to see if it overflows the collection or not. Once I keep doing this over and over again, you will see that your tests will improve because now you are aware of those possibilities. So it's a great learning tool. So now you know all about the cycle. Now you know all the dangers that you can face. Now you know all the things that can go wrong when you are trying to follow something like the testing pyramid. You know how to use mutation testing. You know how to use the test coverage as well. However, the problem is that one day you will need to do a major refactoring. One day you'll need to do a major refactoring, and when you try to bring that feature in that you need to do, but first you need to refactor a ton of code, you will realize that all the promises that someone made about TDD, they are defeated. Because now you need to throw away many tests. Now you don't have your safety net. Now the only thing that you see is a red wall. is a wall of failing tests, of tests that you need to rewrite or discard. And this is the moment, that moment when Simba runs away. This is the moment where most quit test-driven development. It's here because of that defeated expectation. Everyone promised that this will work out, that will be awesome for the rest of our life. But now, I need to throw away tests. That doesn't make sense. The interesting part is that we get stuck here and we abandon it, but there's a major lesson that we can learn to get out of it that applies not only to TDD, but to any types of testing that you have been doing, any type of unit testing that you have been doing. And the problem is that we have this idea that the reason to create a new test is a new method. Remember that I told you that in the refactoring we have the tendency to create new methods, new tests? Usually comes from this assumption. The idea that once I have a new method, a new function, a new class, I will create a new test. Where is false? Sorry. The truth is that the reason to do it, as we have read before by Mr. Fowler, is that the reason is to have a new behavior. If our bookshelf has a different organization pattern for the books, nothing changed from the outside. If now our bookshelf can change shape, if our bookshelf now has light, for example, I can turn on the lights inside of the bookshelf, I have a new behavior. Otherwise, I don't. Let's use a concrete example to make this more clear. Imagine our invoice generator. Now you know that you first write a failing test, okay? Then you start creating the method to take it to green. How do we do it? Copilot, generate all the code in a single method, for example. That's fine. We are still not refactoring it. Then it comes the moment of refactoring. And what we do, we look into that code and we can see a ton of lines, a huge block of text of mapping an external object to a domain object, for example. So we think, this could be an internal method. So we'll extract that as an internal method so I can test it. Because private methods, I can't do it, so I extract it as an internal thing. Problem. Now I write a test against that thing, right? What's the problem here? Is that now I'm coupling my test to the structure of the code. If one day I want to move that internal method to somewhere, I can do it. I'm blocked. That's not the goal. If it's a contract, it should be public. If it's internal, it means it's an implementation detail. And there's reasons to use internal methods, to test internal methods. But in 95% of the cases, it's not a good idea. Okay? If you are building something like an open source project and there's some things that you need to test under the hood, like a subcutaneous test, it's a good tool to do it. But don't overuse it. Let's see another common example. Same case. Write a test, all the code inside of a single method, and now I want to refactor it. This time, I'm not moving it into another method. I'm extracting a class that will map that invoice. Okay? So I write a test against that class. It's covered. But now I need to take a decision on what I do up there, because that class needs the mapper. So what do we usually do? What we usually do is that we'll find a way to have something like an interface being extracted out of this, out of the mapper. And then what we do is that we'll extract that interface, we'll create a test double, a mock, for example, of that interface, and we program the expectations up there. Okay? So now we don't have an overlap between those two. We don't want that duplication. Seems fair, right? Seems like a good idea. What's the problem with this? The problem here is that we are creating interfaces just for the sake of testing. Not a great idea to create an interface. It's not the main reason that you should use to create an interface. That leads to abusing of mocks as well. So now your code has every single test has a mock that has a programmed expectation that when you do a major refactoring, you need to rewrite it. That leads to that failing wall of rev tests. that's a problem. So what should you do instead? I like to use this simple approach. If that dependency makes your tests flaky, slow, and unstable, or in other words, makes it not a unit test according to that definition that now we know, if so, what I will do is that I will use a test double. A mock is a type of test double. There's many others. Otherwise, what do? I use the real thing. There's no risk on that. Let's see it in action. So in that case, what I would do, let's focus on the one on the top. I will test the code directly, but instead of using the mock, I will inject the proper mapper. Because that mapper is not accessing to a database. It's not going across the network. Doesn't depend on the file system. It's just simple logic that is there. But it lives in a different class. So obviously, I can do this to every single dependency. If it's, for example, something that goes across the network, like a database, I still need mocks. Sorry. You roll back. OK, I still need mocks. To this strategy, we call it sociable tests. Okay? It's the idea that you can write tests against something that, in fact, is using other dependencies. What's the biggest advantage? You write less tests. They have more coverage. You are still testing the same scenarios. And the goal is that when you need to change something in the structure of the code, you don't need to rewrite a ton of tests. If tomorrow this mapper becomes, for example, a library that I got from NPM or NuGet or whatever, I can replace it, and nothing needs to be changed on the tests. Because the mapping part was just an implementation detail. That's the big idea. What does that mean in a sentence? It means that we need to test behaviors instead of the implementation details. And the behaviors are accessible through the main class. You don't need the mapper. Yeah, I'm using the mapper because it's a common example. And why do we need to test the behaviors instead? Because behaviors are something that are accessible through public contracts. And one thing that we know about the word contract is that the contract doesn't change as often. So they are stable. On the other hand, implementation details is something that will change, is something that is supposed to change, is something that I want to change, is something that I want to change whenever I want. I don't care. I just want to change it in the way that I prefer. And the test shouldn't suffer with it. If I want to make my code better, I shouldn't think about the tests. That's the idea. Let's use another example. Can I ask for a round of applause, please? Yes? Notice, by the way, don't leave the room yet. We still have a few minutes. The goal here was a round of applause. I didn't say you should start, you should finish. I didn't say the order. I didn't say the frequency. I didn't say something like how loud should it be? How long should it be? I didn't say any of that. The only thing that I say is I need an applause. And I could hear the applause. That was the behavior that I was expecting. The rest was implementation details. What would happen if I came here and I say, this frequency, you start, you finish, all of that stuff? What will happen is that we'll stay here for a long time trying to finally make that test go through. But that's the way that we usually approach testing. And that's the reason why often we get stuck there on that place. Once you get that idea, it becomes so much simpler. It's basically just testing what you do instead of how you do it. With that in mind, I can promise that TDD becomes simpler and easier. You don't get stuck on that place. But if you don't want to practice TDD, once you get used to think about testing this way through the behaviors, all of your unit tests will become better. I promise that. Okay? From my experience, it happens a lot. Usually when people complain about testing, it's because they have been testing the how instead of the what. If you master all of this, you might be tempted to go back to your office and say to your colleagues, let's use TDD, but everyone will say, no, that thing will slow us down. Okay, we need to first write the test and then write the code, and we are always going red, green, refracting, red, green, refracting, and it's so boring, right? There's an answer for that. According to Cambridge, 50% of our time in a programming session is debugging. 50%, according to a study by Cambridge. According to Clockwise, that is a software to track what we do in our computers, developers spend 11 hours per week in meetings. It's a lie. It's so much more, right? We know that. But let's consider it's 11 hours. Also, we spend 6 hours in fragmented work. That means between tasks, for example. Do you know when you just go back to your desk and you are about to start typing code and you get a Slack message saying, do you have 15 minutes, right? So it's those moments. So that means that in a week, in the ideal scenario, we have 23 hours of focus. So that means that from those 23 hours, 11.5 are debugging. One thing that I can promise for sure is that if you practice TDD, most of that time gets back to you. It's productive time. I go months without starting the debugger. But we created this habit that developing is just starting the debugger to confirm the things that we do. Once you start practicing TDD, what you see is that your next action is a step forward instead of trying to find what is wrong. For some reason, the name is debugging. Means there should be a bug there inside, right? But you create the expectation right out of the gate, even when we are writing the code. So at least that time can go back to you. Even then, they will say that. You will say, no, let's not do that. You don't need their permission to do it. I've spent many years in teams where I was the only person practicing TDD. Let's be honest, many of my colleagues didn't know that. Because by the end, we open a pull request. It has tests. It has the code. No one cares. It's just the way that I write code. I shouldn't need a permission for doing the thing in the way that I prefer, in the way that I feel most productive. So you don't need permission to start doing it. Because once you start doing it, you will realize one thing. TDD is like a flywheel. A flywheel is a mechanical device that conserves momentum energy. So in the beginning, it's quite hard to put it spinning, but eventually, it uses the energy, the momentum energy, to keep spinning. It becomes frictionless. You don't need to invest a ton of energy for that. And TDD behaves exactly in the same way. Because in the beginning, it's quite hard. It's so painful to write the first tests before the code. It's so painful to go to a code base without a lot of tests and start adding tests on top of it. It's painful, it's hard, it takes time. However, if you persist, those 6 months that I told you, what you start seeing is that eventually things start to go better. Eventually, the code becomes easier to evolve, simpler to evolve. You start seeing that you keep evolving without going back to other problems. You are using more of your time in a productive way. You don't spend as much time debugging. Eventually, someone might realize that what you are doing, and they want to join you. Because one thing is I'm trying to convince you to practice TDD. Other thing is when you see with your own eyes that it's working for someone else. So you might be curious, and you try to learn it as well. So then, what you see is that the velocity of the team increasing. You deliver more features, less bugs. You don't do as much maintenance work because you don't need it. You keep evolving. And eventually, your client will notice that as well, your clients. They will call your boss happy, saying, now I don't call complaining as much. I'm extremely happy on how things are going. Now you are delivering the things that we asked for, right? Your boss will be so happy, he will give you a bonus. But the best part is that his bonus will be bigger than yours. So everyone is happy. I can promise this, because the energy in the beginning is quite high, that you need to invest. But eventually, it's just natural, to a point that it feels like an addiction, to a point that it feels like an infection. You are just getting out of that curve. So now you master TDD. But you still have one responsibility. Let me go back to my dog. His name is feijão. That is the Portuguese word for bean, okay? A black bean. When he was just a puppy, going for a walk was a nightmare, to be honest. He would bark, jump, trying to hunt butterflies. It was a mess. So I had to ask for help. And I learned that there's one thing that is dog behavioral specialists, okay? Not trainers, behavioral specialists. And in a single appointment, a single class, it looked like a different dog. Doesn't look like the same dog at all. However, what changed on that day was not him. It was me. On that day, I learned that if I wanted to help him, if I wanted to teach him something, I had to listen, I had to observe, and I had to have empathy. It taught me to be a better teacher until the day that I lost him to cancer, quite recently. But what I'm saying is, because once you go out there and you become a master, remember that and observe, listen, and have empathy. And good luck. Thank you. Obrigado.